Hi guys, good afternoon. So today let's start with the wireless. So far we have been discussing about wires only. All the devices we were connecting using wires. Now we will be talking about wireless. So what is wireless? That means you will be connecting your nodes without cables. Okay. And your wireless works on the basis of radio frequencies, radio waves. Okay. So what is RF? RF refers to the radio waves over which your wireless communication is going to happen. Okay. And your Wi-Fi, it uses RF signals or radio frequency signals to transmit the data to the air. Okay. Now we need to understand about the wireless. Why? Because when you don't understand about the wireless, there are chances you might have range problem, you might have interference problem, right? And there are certain materials that can affect your signal strength. Like an easy example, if I give you, if you keep your Wi-Fi router near a microwave, you will not get a range. Why? Because your microwave will interfere with your Wi-Fi signals. So either you'll get signal disconnection or you'll get a very slow speed. Okay, that kind of issues will be there. Now talking about interference problems. So before coming to the interference, let's talk about what is SSID. SSID stands for Service Set Identifier. Okay, so this SSID is nothing but the name of your Wi-Fi. Okay, let's say whenever you want to connect to a Wi-Fi, you see certain names in your device. Those names are what? Those are SSIDs. So SSID is the name of a wireless network. When you are connecting to a Wi-Fi, the name you see is the SSID. So it is broadcasted by your access point so that your devices can discover and connect to the network. But in some organizations, what will happen? They will keep this SSID hidden for security reasons. Why? Because now if you need to connect, then you need to know the SSID as well as the password. Normally, you just see the name, you click on the name, you give the password, you connect. But when your SSID is hidden, in that case, you will have to know the correct SSID also. And that's why in your phones, in your laptop these days, you get an option for hidden networks or like manually add a network. These kind of options you will get. Okay. Now in Wi-Fi, in wireless, we have something called as channels. Your wireless devices, they operate on certain channels. First of all, they are working on frequencies. Okay. So normally, like we say 2.4 gigahertz and 5 gigahertz, 2.40 or 5G, right? So your Wi-Fi operate at 2.4 gigahertz or 5 gigahertz frequency, and right now even it is working at 6 gigahertz also, divided into different channels. So what are these channels? These channels are nothing but also these are frequencies only. Like this 2.4 gigahertz has a range. Same way 5 gigahertz is a range. It is not a single frequency. So in that range, they have total 14 channels. 14 channels means 14 different frequencies are there. And out of those 14 channels, channel number 1, 6, and 11, they do not overlap with each other. Okay. So what do we mean when I say that, okay, they do not overlap with each other? Consider this thing that this is your wireless frequency, okay, which is ranging from somewhere around, 2.40 gigahertz to, let's say, 2.5 gigahertz, something like that. Okay. So there will be one frequency which will say like, which is around, can consider it like 2.410, something like this. Second frequency will be there, which will be 2.417. Third frequency will be like 2.420. Okay, I'm just taking an example frequency. So what will happen? This frequency will be broadcasted in a certain amount of area. Same way, this frequency will be broadcasted in a certain amount of area. Same way, this frequency will also be broadcasted in a certain amount of area. So if you see like this frequency and this frequency, they are overlapping with each other. Same way, this frequency and this frequency are overlapping with each other, but this frequency and this frequency, they are not overlapping. So these are known as what? These frequencies are known as what? Non-overlapping channels. Okay. So in your 2.4 gigahertz, we have total 14 channels, but out of them only 3 channels are there which are non-overlapping. Now, why do we need to take care about, these non-overlapping channels? Because imagine that if we are using these kind of frequencies, then what will happen? These signals, they will interfere with each other. And when signals interfere, we do not have proper communication. Okay. Like, if you have noticed, when we speak over a mic, and if you bring your mobile phone close to the mic, it will start making a beep noise. Now, doesn't matter what you are speaking, but that beep noise will always interfere. So are you able to listen anything? No. The same thing here interference does, that you will not get proper internet connection, speed problem, or disconnection. Okay. Now, why do we need to take care about this? Let's say today, if you talk about it, so we live in an apartment type of building. In one building, there will be hundreds or 200 or 500 flats will be there. Now, each and every flat will be having an internet connection. Everybody will be installing a Wi-Fi, right? So if everybody will be installing a Wi-Fi, that means they will have multiple frequencies. And if they start using the same frequency, same channel, then what will happen? That their signals will cancel out each other and nobody will get an internet connection. Okay. For those kind of reasons, we require non-overlapping channel. Okay. Same way, the 5 gigahertz frequency. So this offers a more number of non-overlapping channels, which will reduce the interference. And if interference is reduced, automatically performance is increased. So non-overlapping channels, these are essential for designing Wi-Fi networks in the crowded areas. Okay, to ensure stable and interference-free connection. This is clear. Now, in a wireless network, we can have certain number of components. So two major components are there. One is your access point, which will be delivering the Wi-Fi range. And in the organization perspective, we will have WLC. Okay, WLC, in the day one itself, I explained that you have a building, multiple access points are there, right? So same device used for managing your access points centrally. This will be used for managing all your access points centrally. Okay. Now access port and trunk port switching, single VLAN member, multiple VLAN members. So we can configure that. And link aggregation, ether channel concept. You combine multiple physical ports into a single port for having higher bandwidth and redundancy purposes. This is clear? Okay. Now, first thing we'll talk about it is the access point. But what is an access point? Although briefly, day one already I explained all these things about your access point, about your WLC. But now let's see about it. So what is an access point? An access point, this is the device that will be delivering the wireless range. So an access point or wireless access point is a networking device that allows wireless capable devices to connect to a wired network. And it is simpler and easier to install your wireless access points to connect all the computers or devices in your network than to use wires and cables. If you want to add devices in your network, in a wired network, you need cables. If you are taking cables, first of all, you need to purchase the cables. Then after you need to take care of managing the cables, those cables, they should not be messy, right? So you have to talk about cable management and all. So many things you need to take care about. But if it is wireless, you just tell them the Wi-Fi password and you're good to go, right? An access point is a device that will create a wireless local area network. See, a switch creates a LAN. Why? Because it is using cables. Now this time we are not using cables, so it is creating what? Wireless LAN or WLAN. Okay. Usually in an office or large building, an access point is going to connect to a wired router, switch, or hub via Ethernet cable. So this is an access point, and this will connect to your switch or network using a cable. Okay, and it is going to project a Wi-Fi signal in a designated area. In a specific area, it will broadcast a wireless range, and any device in that range, they will be able to connect to it. And also these devices, they will be capable of communicating with the wired network. Why? Because switch connects in the same network, access point also connects in the same network. This connect with cable, this without cable. Clear? Okay. Now, what are the benefits? So one of the benefits already you have seen that if you want to connect multiple devices, it is easier when you have the wireless network. Okay. So, if you have employees who are, employees and guests who are connecting with your desktop, laptop, mobile phone, tablet. So if you want to add 20 devices, so adding them on a wireless network, they will add up quickly. Okay. And your access points, see, normally at your homes, when you have your Wi-Fi routers, so you need to provide them with power also, right? So that means anywhere you want to install a access point, their power supply should be there, a power outlet should be there. But nowadays, your access points, they are coming up equipped with the PoE concept. PoE stands for power over Ethernet. Okay, power over Ethernet. That means whatever the cable you will connect from the switch to the access point, through the same cable, power will also come. And if the power is also coming through the same cable, you don't need to install a separate power line or an outlet. So anywhere you can take that cable, you can install a access point. This is clear. So there is no need to run a separate power line or install an outlet near the access point. Why? Because they are coming equipped with the PoE concept, power over Ethernet. And who will be delivering the power? That power will be delivered by your switch. Okay. Then after, another feature is what that you are able to limit the access of people also. How? You can configure IP filtering, you can configure MAC filtering. Okay, these kind of filtering you can configure, and with the help of these all filtering, you can limit the guest access without compromising your network security. Okay, and also you can easily manage the users within your Wi-Fi network who can connect and who cannot connect. For a simple example, let's say at your home you have a Wi-Fi connection. Okay, there is a Wi-Fi router and it is broadcasting wireless range. Now what? Some guests are coming at your home and they say, please give us your Wi-Fi password. Okay. Now they are your guests. You cannot say them no. You have to tell them the password. If you tell them the password, they will use it. Now let's say you don't want them to use it. Okay. You don't want them to use it. So what you can do in your access point, you can go and configure something called as MAC filtering. With the help of MAC filtering, what you can do, whatever your home devices are there, you add those devices MAC address in the access point. Now, even if your guest will take the correct password also, they will not connect. Why? Your access point will not allow. You can show them that, okay, in my device also, I'm typing the same password. They will also type the same password, but they will not get connected and you'll get connected. Okay, so you can tell them, okay, this is company problem. I don't know. Right? I'm not saying you have to try something like this. Okay. But these are things you can do to limit the guest access without compromising your network security. Same things you can do with your neighbors also. Okay. Now, in wireless networks, we can have two types of access points. One is autonomous access points, and second is controller-based access points, or these controller-based access points, these you also know them as a lightweight access points. Okay. These are known as lightweight access points, and these are known as fat access points. Why? Because these are the access points which we are using in homes, which are having their own configuration. If you want to configure them, you have to access the dedicated device itself. But the controller based or lightweight access points, these are the access points which will depend on WLC for their configuration. They will be centrally managed by the WLC. So in the organizations, we are using these. In the home networks, we are using these. Okay. Now, when it comes to WLC, what is the WLC? Already explained, but let's go through the theoretical part. A wireless LAN controller or a WLC is a centralized device in the network, which is used in combination with your lightweight access point protocol to manage your lightweight access points in large quantities by the network administrator or the network operation center. Okay. And your autonomous access points, they are also known as these access points on the network. These are managed, operated, and configured independently. You have to configure them independently. But when it comes to your lightweight access point, the WLC will automatically handle the configuration of your lightweight access points. Okay. So because of its centralized position and brain power, the WLC or the wireless LAN controller is aware of the wireless LAN environment. So WLC will be aware of your entire wireless topology. How many access points are there, to which access point, how many clients are connected, every single information will be there. Okay. And it provides services that can lower the price of deployment and ease the management process and provides several layers of security. So WLC is a highly secure device. Okay. This is clear. Now with the help of WLC, you can configure almost everything that, okay, if there are two users, they will communicate with each other or not. Okay, like you can put them in a different VLAN also, just using WLC itself. And to access the WLC, you don't have to go to the WLC also. Remotely from anywhere in your network, you can access the WLC and you can do the configurations. Okay. Benefits of using WLC. So one of the benefit is that first of all, it is centralized and it makes your configurational part very simple. Okay. And it is secure. It is going to provide you a lot of security features. You can integrate it with AAA. Okay. And you can configure WPA, WPA2, WPA3, all kinds of security also. And also it will be capable of managing your large quantities of access points. Like what we will be using, that will be capable of managing 150 access points. Okay. So that kind of, that number of access points it can manage. So there are benefits. It is secure, it is centralized, and it makes your management very simple. Okay. Now, when it comes to management of your WLC or access point, how do you access? So we know we have two ways to access, either CLI or graphical, right? So when it comes to CLI, we talk about Telnet, we talk about SSH. And when it comes about graphical, we go with the HTTP or HTTPS. Console also falls under CLI only. Okay. And if you're using AAA, packets and radius will be the protocols that will be used for the AAA region. Okay. So these will be used, this TACX and AAA, these will be configured inside your AD servers, Active Directory servers. Dedicated server machine will be there, which will be performing AAA authentication. Okay. Or else you might be having ICE kind of device, Identity Service Engine, okay, which will perform centralized authentication for your entire network. Okay. Now you can manage via Telnet. We know that, okay, Telnet is insecure, transmit data in the clear text. So we go with the SSH. But right now, what we'll be doing, we'll be managing the WLC via HTTP, HTTPS. Telnet SSH, you have already seen how to configure and all. Okay. So you can manage your WLC via HTTP or HTTPS. That means we will get what kind of access? Web-based access. So you will see that initially when we have no configuration on the WLC, when we will not configure any username and password, we can access it using HTTP. But HTTP is insecure, same like your Telnet, transmit data in the clear text. And once you configure username and password, your WLC will not allow access using HTTP. After that, you just have to access it using HTTPS. So HTTPS is encrypted and secure. Okay. Now for your Wi-Fi security, if we talk about your Wi-Fi security, so we have some wireless security protocol. See, initially your wireless network, they used to be open. That means you see the name, you click it, you can get connected. But in one scenario, what happened that your open Wi-Fi network was used for detonating a bomb, remotely detonated a bomb. The terrorists and all, they used it. So after that, Wi-Fi security became very crucial. Okay, so they started designing the protocol. And the first Wi-Fi protocol that came up was in September 1999, which was WEP. WEP stands for, so it was supposed to deliver, same level of privacy as your wired network. Like in the wired network, if you are in the organization, if you are connecting to a cable, you are in the network, otherwise you're not connected. Same way, if you know the password, you can get connected. If you don't know the password, you cannot get connected. Okay, so it was initially expected to deliver the same security level as your wired network, and the secondary function of WEP is said to prevent unauthorized access. How? By asking for password. However, it has been found that WEP is not as secure as desired. WEP is not really very secure. If a network is running on WEP, it takes less than 30 seconds to crack the password. Doesn't matter how long the password is. Okay. Why? Because WEP is used at the two lowest layer of your OSI model, which is data link and physical layer. And that is the reason that it does not offer end-to-end security. Okay. Nevertheless, at that time, cryptography technology was restricted and Wi-Fi devices were limited to 64-bit encryption only. This is very low encryption, easily crackable. And later on, this was increased to 128-bit. But still, how WEP was implemented, how it was working was a problem. Okay. So there were also many security issues in the WEP that made the keys easy to crack. Okay. And WEP was a highly vulnerable Wi-Fi security protocols, and it was finally replaced by WPA. Okay. This is clear. So this was the first protocol, very vulnerable, but still it ran for 4 years. Okay. That means again for 4 years, your Wi-Fi security was vulnerable. So after 4 years in the year 2003, WPA came up. Okay, so your WPA stands for Wireless Protected Access. Wireless Protected Access. Okay, so in the year 2003, your WPA was brought up, and it was nothing but just a temporary enhancement only for the WEP. Why? In the WEP, they increased the cryptography to 128-bit. Here they made it what? So this was definitely better as compared to 64 and 128, but still it was vulnerable. One of the better thing that was done in your WPA was that they brought up 2 different modes, WPA Enterprise and WPA Personal. WPA Enterprise was to be used in the organizations and WPA Personal was to be used in the homes. Because when you're using WPA Personal, you're just giving password only. You're just connecting using password. When you use WPA Enterprise, you require Radius servers. That means AAA servers you require. So WPA Enterprise will perform the authentication using AAA server, and this will just authenticate using password only. So that means if you want to connect to a network which is using WPA Enterprise, you have to give username also, password also. And that username and password should be available in the company's server. If it is not available, you cannot connect. So that was definitely giving some sort of security, but still it wasn't really very secure. And just right after 1 year, in the year 2004, a new protocol was designed, which was WPA2. So in your WEP, the encryption algorithm that was being used was RC4. Okay, RC4 is a secure algorithm, but not as secure as what is used in the WPA2, which is Advanced Encryption Standard, AES. Okay. So in WPA2, what was the biggest improvement made? It was the changing the encryption algorithm. They changed the encryption algorithm to AES. And AES provides higher security and performance compared to your RC4. But again, even your WPA2 is vulnerable. It is secure, but it is vulnerable to 1 or 2 kinds of attack only, not to all the attacks. Okay. So your WPA2 is vulnerable to 2 types of attacks like dictionary attack and brute force attack. Okay. So these attacks your WPA2 is vulnerable. Other than these 2, it is not vulnerable. And that is the reason that this WPA2 protocol came up in the year 2004. And even today, 2024, we are using this protocol. Okay, but for organizations, this is a problem. If their passwords are getting cracked, that is a problem for the organizations. Okay. So there is still a vulnerability that brings security problems because a hacker can get access to a secure WPA2 network and get access to certain keys to attack on the devices, other devices on the same network. So this is the security issue that matters for the enterprise instead of the home network users. And that's why even today in the home networks, we are using WPA2 only. Okay. And finally, a new protocol was brought up, WPA3, which is also known as the next generation by security. This protocol already came up in the year June 2018. Okay. But still it is not supported in all the devices. even till today. Okay. So with the aim to simplify Wi-Fi security, enable more robust authentication and deliver increased cryptographic strength for highly sensitive data markets, WPA3 was proposed by the Wi-Fi Alliance in June 2018. So whatever the problems were there, like dictionary attack vulnerable, brute force attack vulnerable, everything was removed in the WPA3. Okay. So the advent of your WPA3 remedies the protection against the flaws in the WPA2, such as dictionary attack. So these things were mitigated. For public networks like coffee shops or hotels, WPA3 has really good security because what it will do, it will automatically encrypt the connection without need for any credential. It will not ask you for any sort of credentials. It will directly encrypt all the traffic. Your traffic will get encrypted before leaving your device. Okay. So this way it provides high security, but still it is not supported in all the devices. That's why still people are using WPA2. Okay, so organizations, they have shifted here, but if they are working with the old systems, then they still have to use WPA2. This is clear. Okay. Now what we'll do, we'll design a wireless lab. Okay. Go and design a lab. We'll use WLC, and I'll show you how you can use WLC to configure lightweight access points. Now see, without WLC, the access points we have to manually go and configure them. That is a manual task. So right now what we will do is what? Automation. Okay. So I'm not saying right now I'm teaching you automation, but this is kind of automation. Earlier people used to walk the stairs. Now escalators are there, lifts are there, right? Earlier people used to open the doors for airport, hotels. Now automatically happening everything, right? So, not sure here. So what I'll do here, I'll take few devices. So one switch I will take here. Okay. Then we require some wireless devices, like I will take a WLC. So when you practice, make sure you take 3504. If you go with the 2504 or this WLC, they sometimes create problems. So go with the 3504. Okay. So this is a WLC. We need access point. So this is lightweight access point, LAPPT. Okay. So you have to go with this one. So 2 access points I will take. Then for providing IP address to entire network, I will use a DHCP server. I'll use a PC for the admin. And I'll use one laptop as my client. Then let's say I'll use one tablet and one smartphone. This is how our lab is going to be. Let's change the name. And this is WLC. And this is your lightweight access point 1. And this is lightweight access point 2. And this is our server. And this is our switch. This is, let's say, sales department tablet. Okay, so I'll use 3 SSIDs here: HR, sales, and guest. So this is sales tablet. This laptop belongs to HR department. And let's say in our organization, some guests are also visiting. So this is guest smartphone. Yeah. This is the switch, and I don't want the STP process to take 50 seconds. So I'll enable what? Port fast on all the interfaces. Range 0 by 1 to 24. And the port fast. Now let's connect the devices. So immediately you see ports will come up. Okay. Now let's configure the IP addresses. Let's say on the server, I want to use 10.0.1.1. 100. Here I want to use 10.10. Let's say here I want to use 10.11. Clear? Now see. Let's go and configure it. Desktop IP configuration 10.100. Let's say gateway also router's IP is .1. Considering, so I'll configure .1. Then I'll go to the service and I'll configure a DHCP here. Gateway IP address. You want to configure. Let's say my server will start assigning IP address from 51. Okay. And when these guys, they will get the IP address, they should know about the WLC also. So let's say WLC IP address also I will give you. Okay. So that they can know about WLC. Save it, power it on, close. Server configuration is done. Admin PC configuration. Desktop IP configuration 192.168, 10.10, 192.168, 10.1. Close. WLC, so we will configure the management IP. So go to configuration, management. Here, let's say 10.11. Gateway. DNS if you want to configure it with directions. Now let's try to communicate from admin PC to WLC. So we should have the communication. The first packet will drop because of our process, and then we will have communication. Now let's take access of WLC. So right now we haven't configured any username and password. We haven't done the basic configuration. So we will be able to access it using HTTP. I'll go to the web browser. And here, I'll say 192.168.10.lava. And which protocol I want to use? HTTP. I'll say enter. And you see the lights are blinking. So that means communication is going on. So this will take some time. So we will just fast forward it. Now let's go here and check. Okay. So we'll get the WLC UI. Configure the username here and configure username admin. Password, let's say sys0123. Submit. Give a name here. That's the name I'll give, WLC. Then after management IP address, so WLC IP address is 10.11, subnet mask 255.255.255.0, 10.1. Okay. Click on next. Here you can configure one SSID. So let's say I will configure one SSID for the HR. And if you can see, if when I'm saying WPA2 personal means only password. So it is asking me directly password. And if I go with the enterprise mode, it will first ask me authentication server IP address. So right now I don't have the server. So I'll go and personal. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Done. Click on next. And next. So this is the basic configuration we have done. I'll say apply. So when you apply, your WLC will reboot. I'll say okay. Okay. Now your WLC is rebooting. So now you will see that if I try to access using HTTP again, my server will say what? server reset the connection. Why? Because I'm using a vulnerable protocol. So my server will not allow any connection. So which protocol I have to use? Secure protocol. HTTPS. When I use HTTPS, I'll get the URL. Okay. I'll say login. Username that I configure, admin, password what I configure is 0150. And I'll say login. Login, username, admin. This is how my WLC looks like. And you see this is capable of managing 150 access points. This is the information about the WLC, IP address, version, okay, all those information, date and time and all. Then here you can find the access point information, how many access points are there. So right now you can see our access points, they are in the down state. I did not even touch them yet, right? So now if I go here, okay, so that's why it is showing here 0. Now we need to configure here wireless LANs, right? So I'll go to the wireless. You will see the HRV configured, that will already be there. Sorry, not wireless, in the WLANs, wireless LANs. So you can see HR is already there. Now what? Another two we have to create, sales and guest. So here it is create new. I'll click on go. Okay, so let's say I want to create, so profile name I want to give the sales, and SSID also I want to create with the name sales only. Okay, I'll say apply. First of all, I will enable it. Then I will go to security. In the security, I'll go and configure WPA plus WPA2. Okay, right now WPA3 is not supported here. So out of these two, I'll go with the WPA2 and 802.1x. This is for AAA server. So right now we don't have one. So we'll go with the PSK, pre-shared key. That means password. So select PSK. And here password 1234567. Okay. Then you can go and click on apply. Okay. Again, go to WLANs. You can see HR is there, sales is there, and all the working where I'm doing it in the WLC. Again, let's create a new one. This is for guest. And same way we will enable this one also. Enable it, security, WPA plus WPA2, WPA2 policy, reshared key, 1234567, submit, and just apply it. Done. So we can see here all the SSIDs are configured. Okay. Now all we need to do is what? We just need to go and power on these access points. So right now when I hover my mouse over these, the second last line says CAPWAP status, what it is? Not connected. And if you check the IP address on the gigabit Ethernet 0 interface, no IP address, not set. Okay. So I'll just go and power on these access points. This is the adapter, power adapter. You just drag it and drop it to the, okay. Same thing you do it with the second one also. Drag and drop. Okay. Now if I hover my mouse again, IP address received from the DHCP server. Again, if I hover my mouse, CAPAP status is connected and providing WLANs, HR, sales, and guest. Same thing you'll find here. Okay, so we didn't do any configuration. We just powered on these devices. Automatically, they connected with the WLC, took the configuration, started broadcasting the range. Okay, now what? HR guy will connect to HR, sales guy will connect to sales, and guest will connect to guest. So in Packet Tracer, laptop will by default not have Wi-Fi. You have to power off the laptop, then remove this NIC and this WPC 300 and connect this one and power on your laptop again. Then after go to config, wireless. In the wireless, what is the SSID this guy wants to connect to HR? Password scheme was WPA2, PSK, and 1234567 and just close it. Connect it. Sales guy will connect to sales SSID, guest will connect to guest SSID. So tablet and smartphone, they already have a Wi-Fi. So we don't need to do any disconnection connection. Sales, WPA2 PSK, 1234567. And same way from the smartphone also. Yes. Okay. And if this will be down, automatically they will connect to this one because they are providing the same range. Okay. This is clear. So this is how you can configure wireless network. Now, if you want to do the monitoring, I'll go to monitor. And if I scroll down, this time you can see 2 access points are there. Both access points are up. And if I want to see more details, I can just go and click on more details. Okay, these are 2 access points, LAP1 and LAP2. These are the IP addresses, models, MAC addresses, how long they have been up. Okay, and you will see how many devices are connected. So right now it is showing that, okay, number of clients is only 2. But if we will refresh it, then it will show 3 also. Why? Because it takes a little bit of time to update in the Packet Tracer. Okay, so let's say if I want to go and check what are these clients and all. So all these features, they are not supported. Packet Tracer limited feature support. This feature is not supported in the Packet Tracer. So limitations will be there. But in the real access points, you will be, real WLC, you will be able to see everything. Clear? Okay. So this was your wireless network design. Clear? Okay. Now, the last part remaining, automation. Let's automate Q2. See, why I covered wireless today, because now your automation will become very easy for you. Everything I'll compare with the same topology. Okay. So first of all, what do you mean by automation? Automation allows network tasks to be performed very quickly and consistently, reducing the likelihood of human errors. Now, from here onwards, you can start, comparing it with the wireless. How? Your wireless access points. Without WLC, you had to manually go and configure it. Took a long time. When we used WLC, it was done immediately, right? Second, it reduces the likelihood of human errors. Possible human errors are not possible here, right? It can significantly improve efficiency by automating repetitive tasks like configurations, backup, or monitoring. So everything from one single place in one time can be done with the help of automation. So like repetitive task means what? You have to go and do the configuration again and again and again. Like 150 access points, this WLC was capable of managing. But if WLC is not there, 150 access points, imagine configuring one by one. Okay. So it can really improve the efficiency. And automation enables proactive network management through real-time adjustment and optimization. So whatever we will make changes in the WLC, automatically they will be reflected in all the access points also. Okay. Now each and every device is going to have few functions. What are the functions? The functions we call them as a data plane function, control plane function, and management plane function. So what are the data plane function? The data plane function is all about dealing with the data. How you deal with the data? Consider the example of a router. A router, how it deals with the data? A packet will come on an interface. Router will check the destination IP address. Then router will check the routing table, how to reach that destination. And on the relevant interface, router will forward. These are what? Data plane functions. So all the function and processes that will forward packets of frame from one interface to another interface. Those functions are what? Data plane functions. This is clear. Now, I said router will check what? Routing table. If there is no route in the routing table, then router will not forward. That means data plane function will be affected. Something is controlling the data plane function, whether the device will be able to forward or will not be able to forward. And those functions will come under control plane because this is controlling the data plane. Okay, so all the functions and processes that determine which path to use, those all will be under the control plane. That means configurational part will come under control plane. All the configurational part will come under control plane because data plane responsibility is receive the data, check the table, forward the data. That's it. But control plane is all about configurations and creating the tables. So those all functions will come under control plane. What is management plane? Now, how do you manage the device? You use telnet access, SSH access, HTTP, HTTPS access, or console access. These are the ways you access a device, right? These all management, these are all functions that will fall under management. Anything you use to remotely access or remotely manage the device. So all the functions that you use to control or monitor the device, they will fall under management plane. So all the devices are doing these three functions. Every device does it. They will receive the packet, forward the packet. They will have some configuration which will affect the data plane function. And we access the device to manage the device. So in the legacy network, in the normal scenarios, all the devices will have the same three functions. Control plane functions will be there, data plane functions will be there, and management plane functions will be there. That means so far what we have been doing. If I want to configure any single router or any single access point also, I have to manually go there and do the configuration. So far in CCNA, what you learned? Router configurations. You went to the router, you did the configuration. Switch configuration. You went to the switch, you did the configuration. We manually did everything. But imagine right now what we did using the WLC. The configuration of entire thing was centralized in one place. That means which functions were centralized? Control plane functions were centralized. So this was a legacy network when you're doing it manually. And when you're using a controller, your control plane functions get centralized and still the devices, they will have their data plane functions and management functions. This is clear. This is the benefit of using controller. But now tell me one thing, this controller, was I accessing WLC or I was accessing it using an application in the admin PC? How we were accessing it? The WLC, I was managing it from here, right? Admin PC. I was using a web browser. That means even to access the controller, I was using an application, a software application I was using. And this is where it becomes the next architecture, which is software-defined architecture. How? You have your devices which are having their own data plane functions and management functions. You use the controller to centralize the control plane function. Now that controller also you are accessing using application. Okay. So this becomes what? Software defined architecture, or SDN architecture in short. Okay. So here what is happening? If you see, there is two accesses going on at the same time between the controller and application, between the device and controller, right? So if you talk about directions, this is how we write the direction. This is north, south, east, west. So if I apply this rule here, which is this direction according to the controller, this is north, this is south. Okay. So the controller, we say it has two interfaces. So the interface through which it will communicate with the applications, or the interface through which application will communicate with the controller, this is known as northbound interface. And the application through which your controller will communicate with the devices, that will be known as southbound interface. Okay. On the northbound interface, there is an application software running in the controller, which is communicating with the software on system or with an application. So here two applications are communicating. And whenever two applications are communicating, they are going to require an interface. That interface will be provided by API. They require a medium to communicate. Okay, like we also require a medium. My voice is the medium. So here API is the medium. API stands for Application Program Interface. Application Program Interface. So API is the medium for two applications to communicate. Is that clear? And here the API that we will be using is REST API. Okay. And on this side, the controller is communicating with the device. Two devices are communicating this side. And whenever devices communicate, protocols are used. So here, protocols will be used, OpenFlow, NetConf, these kind of protocols will be used. These kind of protocols will be used. This is clear. Now let's see the same thing. SDN stands for Software Defined Network. So in the SDN architecture, we are going to have two interfaces, northbound interface and southbound interface. On the northbound interface, you will be using API, which stands for Application Program Interface. So what is an API? API is a medium for two applications to communicate to each other. Okay. And on the northbound interface, we use the REST API, which stands for Representational State Transfer API, to communicate to the controller. Okay. Southbound interface, it will use OpenFlow, NetConf kind of protocols to communicate with the controller. Okay, because their devices are communicating, and on the northbound interface, applications are communicating. Okay. So REST API, it is one type of API. This is one type in the API. And the REST API, see, API is just providing you the interface, but for communication, language is required. So JSON is the language your REST API will use to communicate between the application. Okay. And using REST API, what are the operations you can perform on the device? So you can create the configuration, you can read the configuration, you can update the configuration, and you can delete the application configurations. So these operations, in short, we call them CRUD operations. Okay. And you use certain tools like Ansible, Puppet, and Chef. Okay. So Ansible is highly used. Puppet and Chef, they have been removed from your current 1.1 CCNA syllabus. Not there. Okay. Because even though your Cisco devices, those were not really supporting these things. Okay. Highly Ansible will be used. Easy, very easy. Understanding purpose, very easy. Ansible is very easy. Now, if we talk about CRUD operations, so we know that CRUD stands for create, read, update, and delete. These are the basic operations that we can perform on the data using the REST APIs. Okay. Now, to perform these operations, see how we were accessing HTTP or HTTPS. So it will be using HTTP messages. In HTTP, we have get message, post message, put or patch message, and delete message. So the get message means to read the information it will use. The post message it will use to create the configuration. The put or patch message it will use to update the configuration, and it will use the delete message to delete the configuration. So these are the methods that are used to perform the operations. And like I said, it will use the JSON language, right? So the data is often encoded in formats like JSON or XML when sent or received via the REST API. So this side, you can see one example of your JSON data. Okay. So this is a simple, you can say like a configuration you want to push in the device. So how do you do it? There will be an object created like this in the curly brackets, and you will have a key value here. This is a key. This is a value of the key. So let's say what is the device host name you want to keep? Switch 01. Interface Gigabit Ethernet 1. What is the IP address you want to configure? This one. What is the subnet mask you want to configure? This one. What is the default gateway you want to configure? This one. And then you can push it to the device. So in case of controllers and when you're using SDN kind of architecture, there are templates. See, my WLC did not send the configuration individually. There is a template we created. We just configured only once. I did not configure separately for lightweight access point 1 and lightweight access point 2. All I did was a template was created. The configuration was there. The same template was pushed to both the devices. Both the devices took the configuration. This is how it happens. Okay. So same like this, a template will be created. If you want to do some other configuration for the router, you will say device name is router. IP address is this. Like this, you will do. You will push it in the device. Device will get configured. Is that clear? So this is how data is encoded in the Jasmine. Same like that, Ansible is also having almost this kind of architecture only. Very easy. Now, if we differentiate between your Ansible, Puppet, and Chef, so the major difference is that Puppet and Chef, they are having a master or agent architecture. Master agent architecture they are having, like they are going to require an agent software to be installed in your devices, like SNMP. Manager was different, and agent program has to be there in the device. But these agents, these are not working very well in the Cisco devices. And that's why we don't use them. Ansible is what? Ansible has an agentless architecture. Okay. So Ansible does not require any agent to be installed. Ansible requires what? SSH configuration should be there. And our devices very well support SSH. This is why Ansible is the most preferred between all these three. Okay. And they are using their own dedicated language. Ansible uses YAML. Okay. Now in the new version, CCNA 1.1, like I said, Puppet and Chef has been removed. Instead of them, Terraform has been attached. Now see, right now we know that, okay, cloud is being highly used. So Terraform is related to cloud and Ansible is related to configuration. So first of all, if you talk about these things, your Ansible is a configuration management tool and your Terraform is a infrastructure as a code. Okay, that means it is a cloud service, you can say. So Ansible architecture, again, it is agentless. Terraform will be agent based. Ansible uses YAML. It supports HCL language. HashiCorp, this is the organization who developed the Terraform. So they have their own configuration language. Dedicated language you have to learn. Okay. Primary use case. So Ansible is primarily used for configuration management and application deployment. And this one is used for provisioning and managing the infrastructure on the cloud. Here, if we talk about support for network devices, so extensive modules are available for Cisco, Juniper, and Arista because Ansible has been there for a long time. And HashiCorp, it is limited. Why? Because mainly focused on cloud resources only. Okay. And cloud support. So yes, Ansible is also supported in the cloud and Terraform is also supported on the cloud. Both are supported. In case of Ansible, there is no built-in state management. You have to push the configurations every time. Here, it tracks the state of infra. Okay. Ease of use. So Ansible has a very easy syntax and it is easy to start with if you want to start with the network automation. And it requires understanding of the dedicated SCL language and state management. Okay, so that's why I say preferred is what? Ansible. Then community support. So both are having large community support also. And example uses, so this is used for automating the configuration changes on the network devices, and this is used for provisioning and managing your cloud resources. So this is one thing extra that have been added. Another thing is that have been added in your version 1.1 is about AI role. So how AI? First of all, AI is what? Artificial intelligence. That means instead of we doing anything, now we are using AI so that we can perform, network operations more efficiently. Okay. So AI driven automation for predictive maintenance and anomaly detection. So AI can easily detect, anomalies. It can find out patterns in your data or your traffic, and then it can easily find out that, okay, this could be possibly malicious traffic. Okay. And it enhances your network security and performance, because network admins, they don't have to focus on, monitoring everything. Monitoring tasks are being done by AI. And even these days, AI can be used to mitigate the attacks also before it happens. How? Even if some sort of malicious traffic is there, AI can take an action. So two types of AI we talk about: generative AI and predictive AI. Generative AI will create new data based on different patterns. So it will look out for patterns and it will create new data, like ChatGPT is what generative AI. Okay. And predictive AI is what? It will look out for your events and it can predict like what is going on in your network. Based on this, it can predict your future events. It is predictive. Okay. So let's say how your network device is doing right now, or how your network traffic is growing right now. So it can tell you that, okay, in the coming 1 year or 2 year, your device will go with 100% CPU users. So that means you need to take care of your bandwidth or you need to upgrade your device. So all these things, it will tell you that, okay, after this much amount of time, you have to upgrade your device, you have to upgrade your network. That is your predictive AI. So what are the use cases? They can be used for network traffic analysis, in the detecting the threats, or in your capacity planning. That, like I said, you can plan your future capacities that, okay, you are going to need an upgrade. So example is predictive maintenance. So your predictive AI, it can predict hardware failures and preemptively replacing components. It can help you in replacing the components that, okay, you need a new device now, or you are going to need a new device. And also they can perform what? Anomaly detection. So they can help you to identify unusual patterns in your network traffic that may indicate a security breach. Clear? Now, instead of doing things manually, AI is doing it. That is only the difference. No, right now it is just coming up. Like Cisco has recently launched AI in its firewall technology to manage firewall policies. Okay, so slowly it will come, because see, AI right now it is in the starting stage. Okay, so there are benefits and there are challenges also. So, like I said, there are going to be challenges. So first of all, let's talk about benefits. So it will improve your overall network reliability and efficiency, as well as it will reduce your downtime and enhance the security. And some tools like Cisco AI Network Analytics and IBM Watson for cybersecurity. Now, what are the challenges? Data privacy concerns. If I'm using a third-party AI, so I might have to reveal my data to the AI, then only AI can tell me something, right? So this is one of the data privacy concern is there. And second is the need of large data set, because for AI to make a decision, it will require a large amount of training data. So you have to give a large amount of data, then AI will give you something. So there are challenges still. So slowly it will overcome. Okay. Now, if we talk about your controller-based and software-based defined architectures, so they are working on these kind of architectures, like overlay network is there, underlay network is there. So these are nothing, don't worry about them. These are fancy terms only. What is underlay network? Your physical infra. Okay, how you connect the devices. So the physical infra over which your overlay network is going to run. Overlay is virtual network. This is your physical network. Okay. So the physical infra over which your overlay network will run, and this provides routing and connectivity services, like how you physically connect the devices. That is your underlay network. Now, this is physical network. This is virtual network, like VPN. Now, VPN is not a physical thing, right? So a virtual net overlay is what? It is a virtual network that is built on top of a physical network. And it facilitates network virtualization and can be used to deploy logical segment like VPN. So these are the architectures. And in the data centers, we have dedicated architecture, network fabric, which will include both underlay as well as overlay. Okay, so this is a flexible and efficient architecture that connects network nodes often used in the data centers. Okay, so this will utilize both underlay as well as overlay to deliver highly scalable and agile network solutions. Okay, so this will give you better network solution. Like they use a different topology itself, different network architectures, spine and leaf architecture they use. Okay, then coming up, you have SD-WAN and SD-access. Now these are things like SD-access. It is used in the LAN side automation. If you want to automate your LAN network, and SD-WAN technology, this is used in the WAN side. So this will be used by your ISPs. And LAN side, it will be used by your large organizations because small organizations, they cannot handle this device DNAC. Okay, if you want to check the price of DNAC, let's see. Very expensive device. Do you see what is this price? Okay, let me just copy it and let's convert it into dollar to INR. How much? Got the idea? Small organizations cannot handle this device. Okay. So this is the scenario. Large organizations are going to use it. Smaller organizations, they will not use it. Okay. They will just look it from far away and find it. They will perform, network automation using Ansible. Manually, they'll do it. Like there will be an automation engineer who will be doing it for them. Okay. And here we have DNAC in the large organizations because this much things they cannot spend on a device, single device. And then now you need a admin for managing this device also. So if you see a salary for SD access engineer, the access engineer salary. Okay. So this is it. Here you can see. Okay, this is just the training. But here, who will actually manage? Got the idea? So this is very expensive for a company. Okay. So like this it is. Okay, this is showing SB some global service. Actually, this is a CCI salary. The access successful job. Yeah, see, this is how they will range. These kind of engineers, they are on a very good batch. See here, 1.84 crores. Okay, so companies will like bankrupt. Okay, so SD access will be used for LAN side automation and SD-WAN will be used for WAN side automation. Okay, so in the SD-WAN, we have devices like vManage, vSmart, vBond, and vEdge. So vEdge is nothing but your customers. Like I am a company, so my edge router. This is what vEdge. And vManage is my controller, where all the configurations and management will happen. And this okay, this vSmart is responsible for delivering these configuration to the vEdges. Then what is this vBond? Now these vEdges, they will not directly connect to the ISP network. First of all, they have to authenticate that they are the correct device. So the authentication will be provided by vBond. The security will be provided by vBond. Okay. And same thing in the LAN side automation. DNAC is the controller And for all the devices in your network, they will authenticate. Centralized authentication will be provided by your ICE, Identity Service. Okay. And for changes in the network topology, they will be updated by your NDP, Neighbor Discovery Protocol engine. Okay. So let's talk about it. Your WAN is what? WAN is a collection of LAN. And Cisco is a, sorry, SD-WAN is a technology, and Cisco has named its SD-WAN technology as Viptela. So actually, Viptela was the organization who developed the SD-WAN. Later on, Cisco acquired it, and it became Cisco Viptela. So SD-WAN is used to manage the devices on the WAN side. So it is used for automation on the WAN side. And here we use vManage, vSmart, vBond, and vEdge. Okay. SD access, it is a technology that is used to manage the devices at the LAN side and used for the automation at the LAN side. You use DNAC, you used ICE and NTP, Neighbor Discovery Protocol. So these are the devices. Now about these devices, how these devices function, how you'll deploy, these things will come under when you come up in the CCI. Yes, it is different topic, different technology itself. Okay. So SD-WAN is different than SD access is different. You will dedicatedly study them when you come to the CCI. Clear? Any doubts? This was your automation and your CCI. Any doubts in today's part? No? Then guys, that's it for our CCNA also completed.
So the security, like what is it? There are PSP, firewall.
So if you come to me, I will take almost all I can take. Mostly I'm taking, we start with ASA, then we go with FPD, then we take after that USA, BSA, CWS, CloudWatch. So many things.
Duration is like how much?
Duration that will depend module to module. Okay, ASA is a different duration, FTD. Then there is one more thing I forgot to mention. NGIPS is there. Okay, so many things are there. Then if you are in the cyber, then I'll take, we'll start from CCNA is there. After CCNA, we can talk about CCP, Linux, PH, SIM, your CCNA is already there. Some things are there. Okay. Okay, so that's it for CCNA. Good luck for CCNP.